All right, hi guys. So this week we're going to be talking more about probability in statistics. And we also talk about understanding uncertainty in this case. We're talking about when we're trying to decide how sure we are about a specific event happening. So that's the main premise of this. So first of all, we do have probability rules that kind of are applicable to any situation. So when we're talking about probability, we do have to make sure that they are between 0 and 1. This also means that they can't be negative, and they also cannot be greater than 1. If you think about it, it's basically saying it has to be between 0 and 100 because probabilities are usually expressed in decimals. Like I said, 0 and 1, so it's the same kind of thing as saying like 0 and 100%. And then our second one is just saying that if your events can't happen at the same time, so if they can't happen simultaneously, then if you want to find the probability that at least one of them occurs, all you have to do is add them together. But once again, they have to be mutually exclusive. If one happens, the other one can't happen, or else this doesn't work. So that is something to keep in mind. You have to make sure that they are independent of each other, can't happen simultaneously, and then you're able to add those individual probabilities together to find that. Our third probability rule is going to be that if you're trying to find the chance of something happening, you take 1 minus the chance of the opposite thing. So sounds a little confusing, but basically you want to understand that if you have something happening and the other thing happening, remember it all has to add up to 1. So whatever these two things are, together they're going to equal 1. So if you took 1 minus one of them, that's going to give you the value of the other one. If you took 1 minus the other one, that'll give you the value, of the first one. So it's basically just saying that the chance of the opposite thing happening is everything except for the chance of something happening. So 1 minus that is going to give you the other opportunity there. Our fourth one is just saying that find the probability of independent events by multiplying their chances together. So once again, we do have to have independent events to use this rule. So all we do here is go ahead and multiply these events together, and that's going to give you the probability of these events happening, of independent events. So, and then the fifth one is just saying that if the ways in which one event can happen are a subset of the ways that a second event can happen, the first event cannot have a higher probability. So the main thing that's saying is that if you have a subset of situations and what the probability is, then the first event in that subset cannot have a higher probability than our second event. So that's just a main rule. If you see a subset of events, just understand that that first event can't have a higher probability than that second event. So yeah. Okay, so expected value is a concept we use in probability, basically just talking about if we were to take a measurement over and over and over again, what will we expect to get in general? Kind of like what would be our average is why we call it the long run average. So if we were to just keep taking measurements, what do we expect to get over all of that? So the way we find that is summing the possible values times probability of getting that value. So an example down here we have, so if you have a 30% chance of making $50, we're going to take 0.3, that's our probability, times 50, which is going to be the amount that we would make. So that's our measurement. And then 70% chance of making $10, so that's going to be 0.7, our probability, once again between 0 and 1, times 10, which is our value, and then that equals 22. So that's the main situation there that we want to make sure we understand, that we're able to add together these different chances of each event. So 30% chance of $50, and then a 70% chance of $10. So that's the main idea there. And then we get 22. So it's basically saying if we were to take this measurement over and over and over again, we'd probably get expecting to get the value of 22 overall. Okay, so the law of large numbers, all this is really telling us is that averages or proportions are likely to be more stable when we have more trials, but then in comparison, our sums or our counts are going to be more variable. So when we have more trials, the two things we keep in mind is that our averages or proportions are going to be more stable. And then also if we have more trials, though, our sums or the counts are going to be more variable. They're going to vary more So, and the law is stating that like this, whatever's happening here is not happening because of a bad run of luck, randomly, because of the fact that they are independent of each other. And then, we say independent trials don't have any memory, because that means when one happens, when the next one happens, there's nothing that's related to the first one, so there's no memory of it. So whatever happens to the next one has nothing to do with the first one. So that's why we're able to make these assumptions in the law of large numbers. All right, so we're going to do some reviews now. So our first one, so true or false, when you flip a thumbtack into the air, it can land point up or point down. So since there are just two possibilities, the chance of each one must be 50%. So go ahead and pause the video and check to see what you think this answer would be, and we'll go over it. So the answer to the first review is going to be false, because just because you have two possibilities doesn't mean that their probabilities are going to be equal. It doesn't mean there's an equal chance of getting both. If you have, the chance of it raining or not raining, that doesn't mean that there's a 50% chance of each. There can be, but not always. So you can't make that assumption just because there's two possibilities. It can be any combination of two probabilities as long as they add up to one. And then also, if you think about a thumbtack, one side is different than the other. One's more heavily weighted, so it might have a higher probability of landing on that one than the other one. So you can't make that assumption. So this answer here would be false for our first review. All right, let's do another one. Okay, so true or false, if your personal probability that the New England Patriots will repeat as Super Bowl champions in 2016 is 0.2, then you must say that the chance that they don't repeat is 0.8. Let's go ahead and try to figure this one out. So if we look at this one, our answer is going to be true, because remember, personal probabilities do have to obey the rule of probabilities. That first, they have to be between 0 and 1, but then also that idea that the chance of an opposite event is 1 minus the chance of the event. So here in this case, let's say the chance of the event is 0.2, and we're trying to find the chance of the opposite event, which is going to be, this is the chance of the opposite event. And so we're looking for that. So remember, the chance of the opposite event is going to be 1 minus the chance of the event happening, which was our chance of the event is that they're going to repeat as champions, which is going to be 0.2. And that's going to give us the chance of the opposite event in this case. So remember, and this has to do with the fact that, they are independent too upon each other. So you're able to do 1 minus 0.2 because together this 20% and this 80% is going to equal 1. So yeah, that's just one of the rules of probability, is I believe our third one. All right, our third review here. So we have a spinner can land in 4 possible positions, so that all 4 positions have the same probability of coming up. So each position must then have a probability between or of which of the following. So go ahead, try this one out. And so the answer to our third review is going to be 1/4. So if we were to kind of draw this out, as if this was our spinner, then also all 4 positions have the same probability of coming up. So if we were to draw this out, this means that they're all going to be equal. Each of these are going to be equal to each other. So then each position has to have a probability of what? So basically all we're looking at here is what probability does each of these have to be in order to add up to 1, because this whole thing has to be a 100%. And then in this case, since they all have the same probability, we want to decide what that would be. So we have 4 different sides here, or 4 different parts of the spinner. So each of these does have to be 1/4, because it's 1 out of the 4 pieces, and they all have to be the same. So then each position must then have the probability of 1/4 because they're all the same, and then it is the probability of one of them happening. So our answer is B there. All right, great. All right, so for our 4th review, we have Skittles candies come in 5 colors and are produced with an equal proportion of orange, red, purple, yellow, and green. A piece of Skittles candy is chosen at random. The chance that it is red or green is going to be what? Let's go ahead and try this one out. So if we were to look at this, our answer is going to be 40%, because if we think about this, since they have, and it says they have an equal proportion of all of them, so we have 1, 2, 3, 4, 5. We have 5 different colors. So if we were to take, 100% divided by 5, we're going to get 20%. So that means that there's a 20% chance of each. So we have a 20% chance of each happening. And then remember the idea that if they can't happen simultaneously, then we're able to add them together to find the probability that at least one of them happens. So we are going to be able to, the chance of red or green, so red is going to be 20%, just like, and also green is going to be 20% because they're each that. So then all you have to do is add these together to get the probability that it's red or green, and then you're able to get 40% here. That's why your answer is C. Okay. All right, so this next one, same idea, but it's just asking a different question at the end. It's the same prompt, but so we're choosing a candy at random, so the chance that they are both red is going to be what? So try this one out. So the answer to this 5th review is going to be 4%, choice A. So remember, these choices are independent of each other. What happens to one isn't going to influence the other. So our chance of red is 20%, remember, as we talked about in the last one, because they're all equal. And then remember, if you want to find out that they're both red, you want to multiply those probabilities. So that's going to be 0.2 multiplied by 0.2. So the probability, this is basically the probability of red times probability of red, which is end up going to give you 0.04, which is equal to 4%. So that is A. All right, I believe we have one more. Okay, so true or false, when you flip a fair coin over and over again, the chance that you get more than 55% of the tosses being heads is more likely for 100 tosses than 1,000 tosses. So what do you think this answer is? So for the 6th review, we do have our answer being true. So remember, our law of large numbers says that getting away from what you expect, so like more than 5%, than that 50% expected in this case. So it's more likely if you have fewer tosses. So in this case, because that means that things are going to be more variable. So when we have fewer tosses here, we're going to be more likely to get away from what we expected to get. So a fair coin basically is saying that we expect it to be like 50-50. So 50%, or 50%. But in this case, if the chance is going to be 55, it's going to be more likely for this smaller amount of tosses here because, if we have fewer tosses, that's when things are going to be more variable in terms of getting away from what you expect. So this is, technically like 5% more than what we expect, 5% more than that 50%. So the tosses being heads will be more likely for this 100 tosses. So this is going to be true because this is the fewer amount of tosses and not for the 1,000 because that's going to be more. All right, awesome. So obviously go ahead and check out the reviews on the YouTube channels. We will have our next group review for lesson 9 on Thursday, October 26th, once again at 8:30. And then, so yeah, if you have any other questions, let me know. If not, you guys can have a great night.